Okay, for mole computation, let's have the definition of mole. Sometimes this is spelled as MOL, so mole with the E and MOL are just the same. This refers to the standard scientific unit for measuring a large quantity of a very small entities such as atoms, molecules, and other specified particles. So the value of a mole, so 1 mole is equal to 6.022 times 10 raised to 23 of an atom, molecules, ions, and or particles. Okay, so going back, nire-represent daw ng mole is a very large quantity. So instead of writing this very large quantity, we are using mole. Kasi if you're going to expand this 6.022, that would be 6022. So that's 3, and then you have other 20 zeros, because we already have 3 here. Okay, so that's 3, 9. Okay, so ganyan karami yung nire-represent ng 1 mole. So instead of writing this very large number, we're going to use mole. Okay, so these are the numbers of atoms, molecules, ions, or particles in a mole. Okay, so mole is a convenient unit to use because of that great number of particles. Okay, and originally, mole is defined as the number of atoms of 12 grams of carbon 12. Okay, so that very big number a while ago, that 6.022 times 10 raised to 23, is known as the Avogadro's number. So we're going to have a relationship between the number of moles. So always, ang conversion natin ay 1 mole of any substance or any element or any compound will always be equal to the 6.022 times 10 raised to 23 atoms, ions, particles, or molecules of that substance. Okay? So, paano yung computation part here? So, example number 1, we have how many atoms are there in 2 moles of water or H2O. So, for this type, we are going to make use of dimensional analysis, or ang other term ng dimensional analysis is unit analysis or factor label method, kung saan nag-cancel out, ginagamit natin as a reference yung mga units para mag-come up tayo dun sa units ng mga given, para mag-come up tayo dun sa units ng unknown. Okay, so dimensional analysis. So we start with 2 moles of water. Ito yung given. Pinapahanap tayo ng atoms. So we make use of the Avogadro's number, which is 6.022 times 10 raised to 23. But going back to the conversion, so we have here moles. So dapat yung i-multiply natin sa kanya 1 mole. So ito yon, 1 mole of any substance daw, dito water. So dito sa baba dapat yung 1 mole para magka-cancel. Okay? Yan yung process ng dimensional analysis. Dapat may cancelling of units para mag-arrive tayo dun sa unknown o dun sa pinapahanap. And of course, since we are after atoms, and andito yung atoms at ang kanyang number ay Avogadro's number, so nandito siya sa numerator side naman. Okay? So with that, the 2 moles of water times 6.022 times 10 raised to 23 atoms of water per 1 mole of 1 mole of water. Okay, so with this, the moles of water will be cancelled and we are left with the unit of atoms of water. So, i-input lang natin ito, 2 times 6.022 times 10 raised to 23 sa calculator natin. Okay? Let's review your calculator. Paano natin isusulat yung times 10 raised to 23 na yan. Okay? So, tignan natin yung mga calculators natin. If your calculator is the newer version, like this one, or if you have this type of, yung black naman, type of calculator, I advise you to have your scientific calculator so that meron kayong function ng times 10 raised to whatever, yung exponent part na yun. Okay? So, sabi natin kanina, 6.022 times 10 raised to 23. Yung, of course, itong mga numbers, dito natin kukunin. Okay? Itong part na times 10, okay, so lakihan lang natin. Okay? So, yung kanina sabi natin, 6.022 times 10 raised to 23. Okay? Itong part na ito, itong times 10 na yan, ang pipindutin natin, hindi yan. Okay? Ulitin ko, this part, ang function na ito yan, dito sa baba. Para dun sa mga new model na calculator. Para dun naman sa black model, ito naman, EXP. Yan ang pipindutin ninyo. Okay, ulitin ko, hindi nyo ita-type yung times 10 na times and 1, 0. Hindi yan. Okay? Rather, yung x times 10x na function dito sa baba at itong exp sa baba. Okay? Tapos, pipindutin nyo lang ng normal yung 23. Itong mga numbers na to, pipindutin nyo lang dito sa numbers, dito sa keyboard, dito sa pad na to. Pero itong times 10, itong function na dito sa baba. Okay? Kapag negative naman, so say for example, ang kailangan mo naman ay 1.078 times 10. So naka-scientific notation, negative 7, say for example. Okay? So, input nyo lang yung 1.07, 1.078 ng normal ito, 1.078. Itong times 10 ulit ay ito. So, ito ang pipindutin nyo. Yung negative part naman, dito nyo kukunin. Okay? Ayan, may negative dyan. Okay? Then, 7 lang na normal. Okay? So, ulitin natin itong times 10 na to dito sa exp or dito sa times 10 raised to x. Okay? Pag may negative dito naman. Okay? So, that's how you're going to input it in your calculator. Okay? Going back. And the product for the solution number 1 would be 1 times 10, 1.0244 times 10 raised to 24. So, kukunin nyo up to the last, okay, especially yung kanyang exponent. Huwag kakalimutang isulat. Okay, atoms of water. So, from there, nako-convert mo na ang moles into atoms using the Avogadro's number and dimensional analysis. Okay. Next problem, how many moles are there in 1 million ozone molecules? Okay, so ang starting point naman natin ay molecules. Ang pinapahanap sa atin ay moles. Okay, so we start with the given 1 million ozone molecules. Going back to the conversion. So ito yung molecules. Large number ang gagamitin natin, Avogadro's number, and then 1 ang unit ng mole. Okay, so for this case, so 1 million ozone molecules, sa baba naman natin ilalagay yung Avogadro's number this time. Kasi para mag-cancel yung molecules at para maiwan yung mole na pinapahanap dito sa problem. Okay, so 1 million divide by the or 1 million times 1 divided by the Avogadro's number. And of course, you're going to have 1.66 times 10 raised to negative 18. Okay, so huwag kalilimutang isulat din yung superscript or yung exponent kapag maglalagay kayo sa mga quizzes ninyo. Okay? So, ulitin natin. If from from a mole. If you are given with a mole and you are required to convert it in atoms, particles, molecules, the you start with the moles, and the multiplier should have the mole on the denominator, and the Avogadro's number should be on the numerator side, so that whatever particles are there would be cancelled, and whatever moles are there will be cancelled, and you are left with the required. But if you are given with the molecules and you are looking for the moles, okay, you start with the molecules, atoms, or whatever large particles there is, and the Avogadro's number will be at the denominator side, so that the molecules will be cancelled and you are left with the unknown or the required, which is on the mole. Okay, so minamanipulate lang natin yung position ng conversion na ito. Okay, ito. Minamanipulate lang natin yung position niya dito sa dimensional analysis para ma-satisfy natin yung pinapahanap. Okay? Now, so that's for the moles and particles, molecules, atoms relationship. Now, we also have molecular weight. Relationship of molecular weight or atomic weight with moles and mass. Okay? Balikan natin yung triangle ko dito kanina. Okay? So if how to use this one, lagi dito sa taas, so we have triangle. Pag nakalimutan natin yung formula, we make use of this diagram. Sa taas ay mass. Okay, this is the mass, and this is the molecular weight, and this is the number of moles. So, paano natin gagamitin ito? If you are looking for mass, okay, so if you are looking for mass, that would be equivalent to molecular weight times, so ito magkatabi sila, times the number of moles. Okay? If you are looking for the molecular weight naman, the unit would be grams. Ito naman dito, divide this by mole. Okay? And if you are looking for the number of moles, it could be computed by mass divide by molecular weight. Okay, so kapag ito nasa taas, nasa baba, division. Pero kapag magkatabi sila, multiplication. Okay, pero kapag merong isang nasa taas, nasa baba, division. Okay, so let's have that formula here. For the molecular weight, for the molecular weight computation, we have the summation of number of atoms multiplied to its atomic weight. So for example, you are asked for the molecular weight of sucrose. So sometimes may mga problems tayo na hindi ibibigay yung chemical formula. Kasi it is expected of you to know how to write the chemical formula, because the last chapter before this one, the previous chapter, ay nag-aral tayo about the naming and writing of formulas. Okay, so dapat hindi nyo kakalimutan yung discussion natin sa writing of chemical formulas. Okay, nevertheless, so sucrose is table sugar. Always bear in mind, table sugar will have a chemical formula of C12H22O11. Okay, i-recap lang natin. So, C12 means there are 12 carbon atoms, H22 meaning there are 22 atoms of hydrogen, and O11 means there are 11 atoms of oxygen. Okay, so the subscript here indicates the number of atoms per element. So, always the subscript follows the element that it describes. Okay, so C12 sa kanya yan. So, ito. Okay, so carbon will have 12 atoms. Ayan. Hydrogen, there are 22 atoms. And oxygen, there are 11 atoms. Okay. Now, anong gagawin natin dito? Each element will be multiplied, or each atoms will be multiplied with their atomic weights. Okay. Atomic weights ay nahanap yan sa periodic table. Hindi nyo kailangang i-memorize yan. Dapat meron kayong periodic table na kalis na doon. Okay? Take note atomic weight. Do not get confused with the atomic number. Hindi yung atomic number ang imumultiply natin for the computation of molecular weight. Rather, it is the atomic weight. Magkaiba si atomic number, magkaiba si atomic weight. Pakitignan yung mga legend ng periodic table ninyo kung ano yung, kung nasaan yung atomic weights. Okay, so from periodic table, carbon has 12, the atomic weight of carbon is 12 grams per mole. So, unit ng atomic weights natin ay grams per mole. Okay, so hydrogen, grams, 1 lang siya, 1 gram per mole. And oxygen is 16 grams per mole. Take note that the atomic weights of elements are unique siya. Walang magkaparehas ng atomic weight. Walang element ang magkaparehas. There's no element that shares the same atomic weight. Okay, so very unique for each element. Okay, so you just multiply the number of atoms and the atomic weight per element. So carbon will have 144 grams per mole. Hydrogen will have 22 because 2 times 1. And oxygen, 11 times 16 is 176. Now, individually, ito yung kanilang contribution. But of course, we are talking about sucrose as a whole. So therefore, you have to sum it up. Kaya may summation doon. Okay, so add everything here, 144 plus 22 plus 176, and therefore the molecular weight of sucrose or table sugar is 342 grams per mole. Okay? Now, what about if the chemical formula is very complicated? Paano natin malalaman kung ilan yung atoms niya? So, example, what is the molecular weight of aluminum sulfate hexahydrate? So, aluminum sulfate, ito siya, because aluminum has positive 3 and sulfate SO4 is negative 2. So, after crisscross, the aluminum will receive the 2 and then the 3 coming from aluminum will be crisscrossed to the side of sulfate. Kaya, ito yung aluminum sulfate natin. Al2SO4 3 and then the hexahydrate is 6H2O. Okay, so meron tayong dalawang types ng number dito. The small number and the big number. Take note that the small number is known as the subscript. Ito yung maliliit na yan. So 2, 4, 3, 2. Subscript ang tawag dyan. Ito namang malaki na tong number na to before the H2O is known as coefficient. Okay. So very useful ang mga numbers na to kasi kailangan natin yan sa pag-compute ng kung ilang atoms ang meron per element. Okay, so ang rule is, of course, we know that every subscript that follows the element, yun yung identity niya, yun yung bilang niya. So, aluminum, Al2, so the subscript 2 indicates that there are 2 atoms of aluminum. But for sulfate, SO4, naka-enclose siya sa parentheses. So, SO4 enclosed in a parentheses and outside the parentheses is 3. Okay? So, for this type, pag merong parentheses, meron kasing outside subscript, the 3, and meron tayong inside the parentheses subscript, which is 4. Of course, kapag walang nakalagay na subscript, ibig sabihin nun 1. Ang gagawin lang natin dito sa mga inside subscript and outside subscript or inside the parentheses subscript and outside the parentheses subscript, you just have to multiply. So, for oxygen, the inside subscript is 4. Okay, inside for oxygen is 4 and then the outside subscript is 3. So 4 times 3 is 12 for oxygen. When it comes to sulfur, the inside subscript is 1 kasi walang nakasulat and the outside subscript is 3. So 1 times 3 is 3. Kaya sulfur 3. Now, pagdating naman kay ito yung kanina kay oxygen. 4 times, yan yung 12 niya. Pero meron pa tayong oxygen dito. So, kailangang pagsamahin yon. Hindi pwedeng paghiwalayin. So, pagdating naman dito kay water, meron din siyang oxygen. So, what we're going to do is, meron tayong dalawang number here. That 6 hydrate, ibig sabihin nito, 6 hexahydrate. Ibig sabihin, sinasabi niya, merong 6 na molecules ng water. So, that 6 is not only for hydrogen, but also for oxygen. Kasi nga, hydrate is composed of hydrogen and oxygen. So, that 6, just like the outside subscript, which has been distributed to the element inside the parentheses, this 6, on the other hand, coefficient of 6, should be multiplied to the element that follows it. So that 6 should be multiplied to the subscript 2 for hydrogen and 1 subscript for oxygen. So we have here coefficient multiplied by the subscript. So the subscript 1 for oxygen should be multiplied to 6, kaya meron tayong 6 here. Okay. So in total, for oxygen, since kanina, outside subscript times inside subscript 4. So, ito yon for oxygen. That's 12. May oxygen pa dito. So, 6 times 1 is 6. And the total of oxygen in aluminum sulfate hexahydrate is 18. Hindi pwedeng paghiwalayin yung 12 and 6 kasi iisa lang naman, oxygen lang naman yung identity nila. So, kailangan natin silang pagsamahin. That's why you have to add them. Okay? And for hydrogen, okay, so sa hydrogen, meron siyang 2, subscript 2, and the coefficient is 6, so therefore, 6 times 2 is 12. Okay, ulitin natin. Okay, so the subscript indicates the number of atoms of that element. So 2, since 2 follows aluminum, so that's 2. The sulfate will have 3, but sulfate is composed of sulfur and oxygen, so therefore, the 3 subscript should be multiplied to the coefficient of oxygen as well as to the coefficient of sulfur. Or in short, the outside subscript should be multiplied to all the elements subscript inside the parentheses. So sulfur will have 3 because the inside is 1 and the outside is 3, so that's 1 times 3. For oxygen, it is 4 times 3. So that's 12. But since may oxygen pa tayo dito sa hydrate, we're going to have the coefficient multiplied to the subscript. Okay? To the subscript of the element that follows it. So that is 6 times 1. So that's 6. And that's for oxygen. For hydrogen, it's 6 coefficient times 2, or that is 12. Okay, so for the molecular weight, again, you have to consult your periodic table and look for the individual atomic weights of this element. Okay, so for aluminum, a while ago, it has 2 atoms multiplied to 27 derived from periodic table, so that's 54 grams per mole. Sulfur has 3 atoms multiplied by 32 from periodic table, that's 96. Oxygen has 18 total of atoms multiplied to 16 grams per mole coming from the periodic table. So the product is 288. And then for hydrogen, hydrogen has 12 atoms multiplied to 1 gram per mole, and that's 12. So the total of all product would be 450. So 450 grams per mole is the molecular weight of aluminum sulfate hexahydrate. Okay? So always consult your periodic table for the individual atomic weights. Okay? So that's for molecular weight. Now for the computation of moles, okay? Moles is, okay, let me just emphasize that the unit for molecular weight or atomic weight is grams per mole. Puntahan natin dito yung triangle kanina. Okay. This is the molecular weight. Ang unit niya ay grams per mole. Okay, so molecular weight is grams. Unit niya ay per mole. Okay. Now, we go to the computation of moles. Okay. Computation of moles is mass of the substance over molecular weight. Kasi kanina, dun sa ating triangle, molecular weight dito, mass dito, at moles dito. Mole. Okay? So, moles could be written as letter N. Okay, so kung N yan, hindi kasi tayo pwedeng, we could not use letter M kasi M is used for mass. So, if we're going to have the triangle, for mass is M, for molecular weight is MW, and the number of moles is N. Okay? So, if we are looking for N, number of moles, it is mass, ito, mass, divide this by molecular weight. Okay? So, para mas madaling tandaan, kaya meron tayo itong triangle na ito. M over MW times N. Okay? So, ulitin natin. Moles always have mass over molecular weight. Okay. So, first problem, how many moles are there in 150 grams of sucrose? Okay? 150 grams. So, we had, ang data lang natin ay 150 grams. Tignan natin yung formula. We are looking for moles, so the formula of moles is mass over molecular weight. For this case, we only have data about mass, that is 150 grams. Laging tatandaan, unit ng mass, grams, kilograms, okay? So, we don't have any data about the molecular weight, but a while ago, we discussed how to compute for the molecular weight of the substance using the subscript and the atomic weights coming from the periodic table. So, kanina, okay, saan natin kukunin yung molecular weight? Yung kung paano natin ginawa ito. Okay? So, na-compute na natin kanina yung molecular weight ng sucrose na 342 grams per mole. So, yan ang gagamitin natin. Okay, so we start with the mass, which is 150 grams, and the molecular weight that is 342 grams per mole. As you could see, grams divide this by gram per mole, grams will be cancelled. And then the mole will go up. Kasi magiging grams. So, syempre, yung grams tsaka grams na cancel na. So, 1 over 1 na yan. Over mole. Okay? So, the inverse of mole. So, itong mole pupunta na sa taas. Kaya ang magiging final answer natin ay mole. Hindi per mole. Rather, ang unit dapat ay mole kasi na-cancel na yung grams. Okay, so just use your calculator, use your calculator. Moles therefore is 150 divided by 342 and that would be 0.44 moles of sucrose. Bakit less than 1 ang answer natin? Kasi nga, sabi natin kanina, for all sucrose, the molecular weight is 342 grams per mole. So, in 1 mole of 1 sucrose, dapat 342 grams. Okay? Ang pinag-uusapan lang natin ay 150 grams, which is lower than 342. So, talagang less than 1 lang yan. Okay? Kasi nga, ang pinag-uusapan natin sa molecular weight ay per mole. Pag sinabi natin per mole, per 1 mole. Okay? Another example. So, how many moles are there in 500 grams of aluminum sulfate hexahydrate? So, again, moles can be computed by mass over molecular weight. So, the mass is 500 grams. Divide this by 450 grams per mole. Saan natin nakuha ulit yung 450 grams per mole ng aluminum sulfate hexahydrate? Balikan natin yung discussion natin kanina. So, molecular weight of aluminum sulfate hexahydrate is 450 grams per mole. Okay, so hindi natin kalilimutan yung steps on the computation of molecular weights. Like this one, hindi ko sinabi kung ano yung kanyang chemical formula. So, dapat i-review ninyo kung paano isulat yung molecular formula niya yan. Okay, so 500 grams again. Divide this by 450 grams. Okay, so that is 1.1 moles of aluminum sulfate. Bakit kaya more than 1? Ulitin natin. In 1 mole of aluminum sulfate, it is having 450 grams. And ang ikino-convert natin ay 500. So, at least talagang justifiable na more than 1 ang ating answer. 1.1. Again, grams will be cancelled. We are left with, we are left with moles. Okay, grams will be cancelled. So, mole done. Okay. And the last, how do we compute for mass? So, balikan natin yung triangle natin kanina. Mass sa taas, baba ay molecular weight and moles. Okay? So, if we are looking for mass this time, okay, so itong maiyo. Mass is equal to molecular weight, magkatabi sila, so therefore times. Molecular weight times the number of moles, or moles times molecular weight. Okay? So, what is the mass in grams of 3 moles of sucrose? So, okay, so 3 moles ang start natin. 3 moles ng sucrose multiplied to yung kaninang na-compute natin, 342 grams per mole. Okay, so kung isusulat natin dito, okay, so moles, 3 moles times 342 grams per mole. Ganyan yan. So, paano na-cancel? Siyempre, may mole dun sa numerator, may moles dito sa denominator, kaya nag-cancel sila. Ano ang number dito pag sinabing per mole? 1. Okay? So, using your calculator, 3 times 342, we're going to have 1,026 grams of sucrose. Okay? So, bakit napakataas? Kasi nga, 3 moles yung pinag-uusapan natin. Okay? Alam naman natin na 342 grams sa bawat isang mole. 3 mole yan, kaya 1,026. Okay? So, units will be cancelled. Our final unit will be in terms of grams. So, nasatisfy natin yung question. Okay? Last example. What is the mass in grams of 0.5 moles of aluminum sulfate? Okay, again, mass can be computed. The triangle natin, mass over molecular weight and number of moles. Okay, so mass is moles times molecular weight. Okay, so 0.5 mole times 450 grams. Ulitin natin, saan natin nakuha yung 450 grams? Wala naman sa problem, via computation of molecular weight. Okay, and that would be 225 grams of aluminum sulfate. Bakit mas mababa? Kasi nga, half mole lang yung pinag-uusapan natin. Okay, 225. Okay, so please do not forget our formula, working formula for mass. It is molecular weight times number of moles. But for moles, if you're looking for moles, it would be mass divide this by molecular weight. And for the computation of molecular weight, of course, you look for the subscript multiplied by the atomic weight per element, and then you add it, because add all the products per element, and that would be the molecular weight. Okay, but for the atomic weight, of course, it could directly be derived from the periodic table.